Pre-Algebra. Today we're going to be learning how to estimate square roots. We're going to be looking at how to do that to the closest integer. We're going to change it into a mixed number, and then we're even able to estimate to the nearest tenth. So last week we learned how to simplify radicals, sometimes being square roots. When that little index number was a 2, that looked something like this, when we had to break it down with a factor tree and pull out in partners, and we ended up with an answer like this. Today what we're doing is using our perfect square number line, which is on the top of the notes if you have them printed out. You might want to pause the video now and maybe jot those in quickly. If you don't have the notes, again, that's okay. Just maybe jot this down on a scrap sheet of paper, because you're going to want to refer back to this again and again and again for these notes and for your Google form that you'll fill out tomorrow. So our first example here, I'm going to skip over kind of exactly what's going on. You'll be able to go back and use those when you're at home alone tomorrow. But for today, we're just going to start by doing the square root of 2. And I want to estimate that. You guys were asking awesome questions in the Zoom office hours and even through email and Remind. And some of your questions, a lot of you had asked were, does the square root of 13 actually equal 13? Well, no, it doesn't, and today we're going to estimate about what that square root of 13 actually equals. We'll start with the square root of 2, though. I have it over here. So the square root of 2, the first thing I'm going to look at is that perfect square number line. That's going to be super important to look at, and I want to know what two perfect squares does the square root of 2 fall in between. So I'm looking at the ones shaded in gray up here. I want to know where, if I had like a range of perfect squares, what would they be? Well, the square root of 2 falls in between the square root of 1 and the square root of 4. So I'm going to write those out. I know they fall in between the square root of 1 and the square root of 4. And I chose those two numbers because they're perfect squares. The square root of 2 is not a perfect square. The square root of 3 is not a perfect square. So I'm only looking at a range of perfect squares. Now we learned last week that the square root of 1, and maybe you already knew this before, the square root of 1 is 1. And the square root of 4 is 2. Therefore, the square root of 2 falls in between the integer, the number 1, and the number 2. So if I wrote out a number line and kind of said like the square root of 2 and the square root of 3 in here, if I had to pick where the square root of 2 is closest to, if I had to say if it was closer to the square root of 1 or the square root of 4, hopefully you would all pick that it's closer to the square root of 1. Therefore, we can say it's closest to the number 1. So if I had to estimate that to the closest integer, I would say number 1, because the square root of 2 is closest to this side. Now I'm going to write a mixed number. My big number, my whole number for my mixed number, is going to be the lower side of my number line. So I'm going to use the number 1. I know that the square root of 2 falls in between 1 and 2. So it's going to be 1 and something, 1 and a little bit. So I have my whole number for my mixed number. Next, I'm going to make it into a fraction. I want a whole mixed number here. I have 1 and what is my fraction going to be? I find that out by using my perfect square number line for my denominator. So 4 minus 1 is 3. That's going to be my denominator every time I do the bigger perfect square minus the smaller perfect square. Now to get the numerator, I'm going to do the square root of 2, my given square root, the one that I'm trying to estimate, the square root of 2 minus 1. Well, that is 1. So we just estimated the square root of 2 to the closest integer and to the closest mixed number. Next, I'm going to do a tenth, and this one's easy because hopefully everyone out there knows that 1/3 is just 0.3 repeating. So I know that the tenth for this, and tenth for a decimal place means 1 place. So my my square root to a tenth, estimated to a tenth, is 1.3, just 1 decimal place. So we just estimated that in 3 different forms. And if that was confusing, we're going to do a few more examples. As soon as you become comfortable with these examples, you can stop. You don't need to watch all of them. They're all kind of the same, all 6 on this page. So as soon as you're comfortable with it, just stop and kind of be done with it. For those of you that want more examples, hang on and keep watching. So for the square root of 8, I'm going back again, sorry to make you dizzy, I'm going back again to my perfect square number line, and I want to know, where does the square root of 8 fall? So I'm looking at these gray boxes up top, and I want to know, where does the square root of 8 fall? Well, it falls in here. It's in between 4 and 9, so that's what I'm going to use as my 2 endpoints for my number line. So I'm going to write those up here. I have the square root of 4 and the square root of 9. And based on the number line, or maybe you already know this, the square root of 4 is 2. The square root of 9 is 3. Therefore, when I'm estimating the square root of 8, I know that that number, the square root of 8, is going to be in between the number 2 and 3. So it's going to fall somewhere in there. Now, if I had to pick if 8 was closer to 4 or closer to 9, that's definitely going to be closer to 9. So if I had to pick the closest whole number, the closest integer, I'm going to say that that's closer to the number 3. So the square root of 8 is closer to the square root of 9, and I know that equals 3. So it's closer to the number 3. Now for my mixed number, my whole number inside of the mixed number that I'm going to use here is going to be 2. I'm going to use the lower end of my my number line here. So I'm going to use 2. Well, 2 and what? I need the fraction part still. So with the square root of 2, remember we subtracted those blue square roots that I'm using. So 9 minus 4 is going to give me 5. That's going to be my denominator. My numerator is figured out by doing that given square root, the one that I'm trying to estimate, the square root of 8, minus the square root of 4, the lower end. So 8 minus 4 gives me 4. So I have now, it's closer to 3. My mixed number is 2 4/5. And now for a tenth, everyone in here hopefully knows, if not, you can divide it out. We'll have to divide it out when we get to ones with denominators that are larger. But 4/5 is equal to 0.8. So therefore, when I estimate to the closest tenth, I have 2.8, and I'm done. That's it. So if you feel comfortable, you can stop the video, fill out that Google form. If you're not comfortable, let's watch another one. I'm going to go down to the square root of 13 for this one. Now the square root of 13, again, I'm starting with that perfect square number line. I'm looking, where does the square root of 13 fall if I had to choose? Well, it's right in here. 13 falls in between 9 and 16. So I'm going to write out my number line here. I'm going to say the square root of 9, that's my lower end, and the square root of 16, that's my higher end. And the square root of 9 is 3, because 3 times 3 is 9. The square root of 16 is 4, because 4 times 4 is 16. So that's the range of numbers we're working with here. And for my integer, if I had to choose, is 13 closer to 9 or 16? It's closer to 16. Therefore, we would say the closest integer is going to be 4. To move on to my mixed number, I start with the lower end of that range, and I'm going to use a 3 as my whole number. Well, 3 and what? Let's figure out the fraction. The fraction we figure out by subtracting that whole perfect square number line, the bigger number minus the smaller number. 16 minus 9 is going to be 7. That's my denominator. And now for my numerator, I do, what am I trying to estimate? Well, I'm trying to estimate 13. And I subtract 9. I subtract the lower end. 13 minus 9 gives me 4. So I have my integer, it's closer to the number 4. My mixed number, I'm getting like more specific. It's 3 4/7. Now for a tenth, this one's kind of annoying. We're going to need to do some division out unless you know exactly what 4/7 equals. If you were taking MCAS, or if we were in school taking a test in this, you would not be able to use a calculator. So challenge yourself and try to do the long division out. But let's face it, we're all at home. So if you wanted to get used to it using a calculator, that's totally fine as well. What we need to know is, what is 4/7? For my tenth down here, I know it's 3 point something. And up here, we knew that 1/3 was 0.3. And we knew that 4/5 was 0.8. But down here, maybe we don't know what 4/7 is. So we can do some long division out to figure that out. And what this means is 4 divided by 7. So if a little lesson, we'll go back to 6th grade, maybe 5th grade. 4 divided by 7. I'm going to set it up like this. So I'm dividing the 4 by 7. Well, does 7 fit into 4? No, it doesn't. So I'll hold the place with the 0. I'm going to bring my decimal point up. How many times does 7 fit into 40? Well, 40 divided by 7, I know 7 fits into 35 5 times, so I'm going to put a 5 up here. 7 times 5 is 35, and you subtract. I have 5 left over, and I'm going to bring my 0 down. 7 fits into 50. Well, I know 7 fits into 49 7 times, so I'll put the 7 up here. And when you're doing your long division out, do it out to 2 places because we want to know if we need to round or not. If you had stopped here, you probably would have said, well, it's about a half, about 0.5. But when I bring it out to my hundredths place, 2 decimal places, I see that that 7 is going to bump that 5 up to a 6. So this is actually going to be 3.6 if I estimate it. And you guys can go ahead and try that on your calculators too. At home, type in the square root of 13. It's not going to be 3.6 exactly, but it's going to be pretty close. All right, let's move on. I think we'll do one more, and then maybe we'll stop and leave those last 2 for office hours if you guys want help, so the video is not super long. So for square root of 20, I'm going to look up here. I'm starting with that perfect square number line. I see that 20 falls between 16 and 25. So that's going to be my range of numbers I'm using. 16 is the bottom end of my perfect squares, and 25 is the top end. Now the square root of 16 is 4. The square root of 25 is 5. And I want to know what integer, what whole number is that going to be closer to? Is 20 closer to 16 or 25? And if you don't see it right away, you can always write the numbers out. I'll do it up here quickly for you. So 16, 17, 18. So I'm looking, is 20 closer to 16 or 25? Well, this is the halfway point, so it's closer to 16. If it's closer to the square root of 16, that means the square root of 20 is about 4. So we'll say 4 for my integer there. Now for a mixed number, I'm going to start with the lower end, and I'm going to use 4. I need 4 fraction for mixed number. So I get the denominator by subtracting. 25 minus 16 gives me 9. That's going to be my denominator. My numerator is going to be made up of doing, what am I estimating? 20 minus the lower end. 20 minus 16 gives me 4. So I know it's about 4. The square root of 20 is about 4. Getting even more specific, 4 and 4/9. And for a tenth, I want to know what is 4/9 equal to, because it's going to be 4 point and whatever we figure out 4/9 is. A little trick for your 9s, whenever you have a 9 in your denominator, we know that the numerator is just going to repeat for the decimal. So 4/9 just equals 0.4 repeating over and over and over again. So we know that this is going to be 4.4. So if you have any questions, guys, you can go ahead and email me, remind me, or Ms. Remsen. And if you have more questions than that, then there'll be Zoom office hours. So watch your email for that code. Those Zoom office hours are kind of like extra help. Like if you stayed after school or came up for discovery, that's what those should be used for. So hopefully we will see some of you tomorrow. And if not, hopefully you got it. That'd be cool too. We will talk to you soon. We miss you all, and we hope we're back to AMS soon. Bye-bye.